Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are discussing electromagnetic waves, paper 1 for core and extended candidates. We have classwork. Let's start by KWL chart. You can find KWL chart if you join the Telegram channel. Please, you have to write down what do you know about electromagnetic waves, what you want to know, and at the end you have to write down what did you learn. And kindly, if you would like to write in the comments what did you learn after discussing electromagnetic waves. Okay, let's start by question number 1. We have different parts of electromagnetic spectrum, and we have what are the uses, different purposes. Below we have 4 statements, and you have to read them all carefully and choose which statements are correct. Let's discuss each one. Infrared waves are used in television remote controls, right? Radio waves are used to transmit television pictures from satellites to Earth. No, this is incorrect because microwaves are doing this. Ultraviolet are used for intruder alarm. We will discuss intruder alarm in electricity, and it's not ultraviolet, so this is incorrect. X-rays are used for security checks, right? When you go to the mall or airport security check, we are using X-rays for security check. It's correct. So statement 1 and statement 4, they are correct. Let's move to question 2. Radiation from which part of electromagnetic spectrum is used in the remote control for television? We said this in question 1, it's infrared waves. We use them in remote controls. Okay, and we have other uses for infrared. Please write them in the comments, and you can also follow our Instagram account. You can find more RBL questions, research-based learning. We have research day for general knowledge, and we are discussing important points. Okay, question number 3, we have diagram representing electromagnetic spectrum, and please guys, this is very important. You have to do it by yourself. You have to write in 2 different ways, starting by radio waves here at the left side in this direction, going to gamma rays, and then write another one starting by gamma rays here to radio waves. Okay, you should know them in the 2 directions, in 2 different ways. Okay, back to the one we have in our question. What happens here? You have to learn them in order. We have radio waves, and some regions have been labeled and some labels are missing. Which one will be infrared? You know them in order. Radio waves, we have microwaves, we have infrared, we have visible light, we have ultraviolet. You can remember that in visible light you have red here and you have violet here. So you can remember that you have the space or the segment before visible light is red, and the one beyond the visible light is ultraviolet. Okay, let's discuss quickly what happens here. What happens? So the answer first, the answer for this one, asking you about infrared waves. So the answer is B for sure. Okay, but I would like to remind you that if you have radio waves at the left hand side here, so in this direction, what happens in this direction? The wavelength decreased and frequency increased. I have to erase this. Okay, so what about the speed? According to wave equation, you know that speed is equal to wave speed is equal to wavelength times frequency. But here we are discussing the change in wavelength and frequency. They are not constant. Not one of them is constant. So if you have the wavelength is decreasing, the frequency should be increasing, so the product will be the speed, which is same, which is constant, which is same speed of light in vacuum, approximately is 3 times 10 to the power of 8 meter per second. So this one of the features that all the members of electromagnetic waves, they have in common. All of them travel at the same speed of light in vacuum. But according to the position or the location of this member in the electromagnetic spectrum, you can detect if the wavelength is increasing or decreasing, the frequency is increasing or decreasing. Okay, so this is very important. So you can say that gamma rays, they have the highest frequency. Radio waves, they have the longer wavelength. So you can write here, longer wavelength, lower frequency. But gamma rays here, they have shorter wavelength and they have higher frequency. Is it clear? Okay, let's move to question 4. Question 4 is challenging. We have here common uses for 3 types of electromagnetic waves, which correctly identifies the waves. We have satellite television and we have terrestrial television. What is the difference? The main difference, and which is not satellite. Okay, this kind of television, terrestrial one, they are television broadcasting in which signal transmission takes place via radio waves. So they are using radio waves, not microwaves. So terrestrial television, they are using radio waves, broadcasting, transmitting signals using radio waves. Okay, but satellite television, they are using microwaves. So this point is very important. Television remote controls, the remote controllers, they are using infrared for sure. So which answer here is correct? It is B. So satellite television using microwave, and you have here the one which is not using satellite, it's radio waves. Okay, and we have television remote controllers infrared. Is it clear? This is very important. Question number 8. It takes 0.24 seconds for a microwave signal to travel from a transmitting station on Earth to a satellite and then back to the station. Okay, you can imagine that you have here Earth and you have an orbit and you have the satellite. Okay, transmitting signals. You have here a station. the microwave signal travel from transmitting station to a satellite in this direction and back to Earth. Okay? It took 0.24 seconds. Okay? The speed of microwaves is mentioned. How far is the transmitting station from the satellite? So you have to calculate the distance. You know that by applying speed equation, that speed is equal to distance traveled divided by time taken. The speed is given already. You can rearrange the equation first. So the distance is equal to speed times time. The speed here is 3 times 10 to the power of 8 meter per second. Check that you have consistent units times. The time mentioned here is the time taken by the signal to travel from Earth to the satellite and back from the satellite back to Earth. So you have to divide this value of time, you have to divide this value by 2. So it's 0.24 divided by 2, it's equal to 0.12 seconds. Okay, so the time here should be 0.12. You have your answer. It will be 0.36 times 10 to the power of 8 meter per second. Simplify, it's 36 times 10 to the power of 6 meter per, only meters. We are calculating distance, so the answer is meters. Okay. Since you checked already that you have consistent units, but the choices you have, it's not including your answer. All the answers in kilometers. How to convert? You can convert from meter to kilometer. You have two options. Either you have to divide by 1000, and for extended candidates, you know that if you divide by 1000, it's the same as multiplying by 10 to the power negative 3. So if you multiply your answer times 10 to the power of negative 3, you got your answer in kilometers. Okay, so you have your answer 36 times 10 to the power of 3, which is 36,000 kilometers. So the answer is A. Okay guys, so you have your answer. I have to remind you that you have to check your answer to be realistic. For example, if you got your answer 36 meters, for example, this is not realistic. Okay, so you have to check consistent units. You have to write your answers in standard form, scientific notation, and you have to check that your answer is realistic. Don't just write down what your calculator produce.
Subscribe for more videos. I love Physics Blender. I love Physics Blender. I love Physics Blender. I love Physics Blender.